Okay, so in this video I'm going to explain a little bit of how can we solve equations that have an x and the exponent of the form something like this. So pretend I want to solve 5 to the x equals 1,000. So we don't have a way to do this right now. We can guess and we can approximate. We know that 5 to the 3 is 125, so it's too small. 5 to the 4 would be 625, I believe. It's still too small. And 5 to the 5 would be way too big. 5 to the 5 would be 3,000 and something. So these are things maybe between 4 and 5. Okay, but we don't know exactly what it is. So that's our goal. Our goal is to solve this. And I'm going to leave this on the side and say, okay, this is our goal. Let's keep this here in the corner and see how we can get back to it in a minute. Okay. So now let's remember what we know so far. So far we know that the thing about logs is that the log base b of x equals y really means that b to the power of y equals x, correct? So let's think a minute, how would I try to know, how would I know what is the log base b of x to the m? Well, I'm not that far off. If I know that log base b of x is y, well, I need to know, I can, from here, I can deduce that x to the m, right, should be by b to the y to the m. That just means that x to the m is b to the m times y, correct? Because you multiply the powers. So there you go. That's our answer. To solve this question up here, I need to know what is the power I need to raise the base b to get x to the m. I just found it. It's right here. The power is my. Okay? So, using this little fact that I just figured out, I can know that my answer is, my answer is my. Right? Log base b of x to the m is my because b to the power of my gives you x to the m. Okay, let's go back to this. Log base b of x was y. Let's write it down right here. It's m times the log base b of x. And this is the property I'm looking for. Because what I'm seeing here, I'm going to make some space here. What I'm seeing here is that if you see this, what I just found, I'm going to write it very crystal clear over here, where we found that log base b of x to the m is nothing else but m times the log base b of x. Okay, and all we did was use a definition of the log. So this is pretty big. Okay, the expression is right here. I hope it's clear. You can ask questions if it's not. The most important thing is that you can see how this power up here brings down to the front. Okay. Okay. So let me make some space and tell you how we use this, how we can use this to solve our original question. So I'm going to grab this. See if I can grab this here and put it here in the corner. Okay. So those are my two things that I know now. Oops, I raised this to the side. There it is. So I'm going to go back to our problem. Okay. So if I want to solve 5 to the power of x equals 1,000, what I'm going to do to solve this is I'm going to take the logs on both sides. Which log? That's the cool part. It doesn't matter. I can use log base 10 that I have in my calculator for both sides. So I'm going to use base 10 because this side is a power of 10. But if it's not, it still works. And I'll do more examples with that in more videos. So take the log of base 10 on both sides of this equation, and I'll have log of 5 to the x equals log of 1,000. So, like we said, the right side is pretty simple. This is just, it's base 10, so it should be 3, right? 10 to the 3 is 1,000. So that's how I get that. Okay, so let me leave this aside. Now on this side, I'm going to use a property that we just learned. This power x can be brought in front, and I'm kept with here with a log 5. Right? I'm using the property here that we just learned about. The power is a little bit mismatched, right? Here the m is my exponent. Here the m is my exponent, while over here x is my exponent. But if you recognize that, in this case my x is the 5, so my b is a 10. If I don't have a base, it's base 10. So that power is brought to the front, like it is here, so that power is brought to the front. So now log of 5, I can find that from the calculator. I can do, I'm doing it right now. If I find my log button, and I get 0.698. So once you figure that out, this is just a matter to write it down. You have x times 0.69, sorry, 6989. So I'm going to write 699. Okay, equals 3. So I'm done. I know that x would be equal to 3 divided by 0.699, which is approximately to 4.29. If I put no decimal, it will be 4292. Okay, so I got my answer, and well, let's check. Let's check that this works. So let me select this guy and see if I can put this to the side like I did the other stuff. Okay, I missed part of the 9 here, so let me, there you go. So this is my answer. Let's check that this works. I mean, you're not going to see my work in the calculator, but if you put this in my calculator, I'm going to say, I'm going to do 5 to the power of 4.29. So I want to put in my calculator, and I'm getting 5 to the power of 4.29. I get 996.73. It's not 1,000, and that's because I rounded, right? I rounded here when I put this as 629, right? 699, it was 69 something, and I rounded here, right? So it's not going to get exactly 1,000. But this is my approximation, and this works. Okay, so I'll do more videos explaining how to use this.